So my name is Patrick Rainsberry. I'm the technical manager with SolidWorks Corporation, and today we're going to be talking about I believe the title is breaking down the barriers between electrical and mechanical designers. So we're going to be talking about obviously not going to do a demo on their little IBM here, but we're in booth 3401, like kind of catty corner across the convention center from here. If you guys want to see anything that I talk about, if you guys want to see like a demonstration of any of that stuff, you can come over to our booth and I'll be there, and we're also doing other like live demos. But I mean, the idea, right, what I want to talk about for this particular session was just kind of like some of the trends that we're seeing in electronics design. You know, I have the fortune of working with so many different customers I cover like the Western area, and so like I get to see all kinds of different things that people are doing, really, you know, like what some of the people who I think are kind of like not necessarily the leading edge, but really just kind of people who are like taking like advantage of the tools, you know. And so I just want to share some of the stuff that I see in the industry, and then some of the stuff that we're doing with our particular products to kind of address that stuff. So I mean, if you look at like, you know, kind of obvious, right, but the trends in product design, which is, you know, increased complexity, denser packaging, definitely aggressive cooling requirements, RoHS compliance, and you know, just like more and more with embedded systems, right? And so it's like, how do we take advantage of tools to address these needs? You know, I mean, especially you start talking about, you know, the smaller and smaller packages with the higher and higher power components, obviously cooling becomes more and more complicated, right? And with more and more different types of devices to handle cooling. So what are the challenges that you guys are facing? I mean, I'm assuming, are most of you guys here either are SolidWorks? How many of you guys are SolidWorks users in this audience right here? So most of you guys. And how many of you guys are actually like designing PCB boards, like electronics boards? Nobody? How many of you guys are working with guys who are designing PCB boards? And how many of you guys have to make sure that those PCB boards don't overheat? Nobody? Two guys? One guy? Well, I'm going to talk about that anyway. You know, and then obviously the complexity of the ECAD stuff, right? Because how many of you guys are involved in things like cabling design and cable placement? Yeah, so a lot of you guys are doing cabling, and you know, so when you start talking about integration of cabling, I mean, I guess this type of show is probably a lot of controls guys. But you know, if you look at the process, you know, from component specification, the actual packaging design, and then with the PCB designers, prototyping, and then like the whole manufacturing release and management of your document system. You know, how does SolidWorks, what can we do to kind of fit into this process, right? So, you know, when you look at all these different components of that process, you know, I think that we don't really need to go through this in detail. You know, we know what these things mean, but, you know, it's like we have ways to help you in each one of these steps, essentially, you know. So if you look at, you know, some of these might be tools that you guys may or may not realize are available, but I'm just going to kind of walk through this. So when you talk about component specification, how many people have used 3D Content Central before? You know, a lot of you guys, yeah. So, you know, the 3D Content Central, it's like every day there's just more and more content going up on there. You can access it from the SolidWorks interface. If you just go up into the search tab, you just can drop down, you can see 3D Content Central, and there's all kinds of people put their models up there for you to use. And then, of course, like the material properties library is getting bigger and bigger. That helps with that. Packaging design, you know, we've done a lot with just being able to like make it easier to use configurations and like set those up. And I'm kind of like this presentation, I just kind of want to put a lot of like keywords in your heads, and then if you want to like come and see that later, we can talk about it. But you know, with we've done a lot on one of the things that we did in the last couple of releases. I don't know, it's really important for electronics, I think, is instead of just being able to do like interference detections, it's also being able to do clearance detections to make sure that you have like a minimum clearance between components and housing and whatnot. So that's another new tool that's pretty new. And also we've done a lot with routing in the last couple releases for being able to actually take the cables that you do in electrical routing and then be able to flatten them out in a 3D flattened route. For PCB design, obviously we don't do PCB design inside of SolidWorks, but we work really well with the companies that do. So since we bought Circuitworks in 2008, we've been able to directly read in and create 3D models off of IDF files. And in the last few releases, we've done stuff to enhance that as well. And then also being able to make changes to the boards and then push the board back out to Circuitworks. Prototyping, obviously direct translation to rapid prototyping machines, as well as being able to do simulation for, virtual prototyping. I hate to use that word, but that's really what it is. Being able to just like do cooling simulations inside the software, and then being able to do things like automatically generate drawings for the wiring harness, and then being able to use a PDM system to actually manage like a release process for not just SolidWorks, but also for electronics components. So see, these are some of the things. We did this big study at SolidWorks on the electronics industry and how people were using our tools. And so these are some of the things that we took back from that, from some of the different customers. And so I just pulled out like some key points from a bunch of the different case studies, which was like, being able to reduce time, we call it time to effectiveness for new users, was a pretty good one by 50%. Just talking about like a new engineer coming on board and getting up to license on the tool. Cutting CAD costs, reducing the design cycle, lowering development costs, and then also reducing tooling design. Here's an example of some of the customers, just in this a general slice of just different types of electronics type, from telecommunications to underwater robots, computers, obviously, hard drives. We're pretty big in like all kinds of electronics components. Hard drives is a big area for us. Consumer electronics, Garmin, for example. This is an interesting company, In Focus. These little projectors, these guys made these projectors that are, so I carry one of these around with me actually, this L20 mobile projector. I mean, talk about like taking something that's really hot and dense and putting into a small package. Their projector's only like this big, but if you know what I mean, it's doing what that does, right? And so obviously the cooling requirement on that thing was insane. And so they had to do a lot of stuff with being able to do flow simulation to really understand like how they could make sure that this thing wasn't going to overheat, because that these bulbs put out really serious power. Echo is another cool company, making like interesting lighting components. DAP does another consumer product type of product. So we look at the SolidWorks philosophy to fit your needs. So this is kind of like our new mantra or whatever, but being able to have like complete design solutions to use across the enterprise with an open architecture and being responsive to our customers. And that's really the key. We want to be able to just, whatever it is that you guys need to do is what we want our software to be able to do, right? And so you can see that we've really expanded, from 6-7 years ago, where we really just mostly only focused on design, to being able to to not only design the components, but being able to do simulation, being able to publish those designs, using some really interesting tools for creating user manuals and stuff, and then being able to manage all of that data together, whether it's the SolidWorks data or the PCB. And I'm going to just kind of walk through these 4 areas right now and talk about some of the stuff just really specific to SolidWorks. So, obviously SolidWorks CAD, I asked who used SolidWorks CAD. Everybody in here uses SolidWorks, right, and what's in this presentation. So I don't need to tell you that it's a great tool for creating 3D models, 2D drawings. I was expecting there to be like half SolidWorks guys, half like PCB guys, so just skip through some of this basic stuff. But the basics of SolidWorks CAD, right? Things that are really important, I think, for electronics. Obviously sheet metal, if you're doing that type of electronics packaging, drawing creation, routed systems for electronic cabling, or piping and fluids if you guys are doing like hydraulic stuff. Another really key, so how many of you guys in here are using Circuitworks? Who said that they work with PCP guys? A few of you guys? So for those of you guys who haven't seen it before, what Circuitworks does is it's a bridge between mechanical and electrical CAD tools. It allows you to take the 2D IDF file. So like the guys who are working in something like Allegro or something like that, they're pushing out a file that looks like this, right? And then what we do is we import this file, and then we allow you to either just automatically take basically the footprints from Allegro or whatever CAD tool, and then extrude those out to their height, or you can actually have a library of mechanical components. Like you see here, there's like this screen and some of these chips where we have a SolidWorks model of it, and it'll actually like place that on the board based on the PCB layout. So you can build up like a really accurate 3D model of the PCB design based on files in your library. So that's like really one of the things that people are doing to really kind of, the guys who are really using this extensively and have like really good accurate models and like good naming conventions back and forth And you can also use it to track keep out zones and board layouts. And then the mechanical engineers can make necessary changes to keep outs and board design and then push that back to their electrical guys. So again, if you want to see some of this in more detail, obviously I can't do the demo, any kind of demo here. Also, I think I only have how am I on time? 5 minutes? Okay, I'm gonna go super fast and I think I have more time. So electrical routing, for those of you guys who know that, that's to be able to basically lay out cables in 3D. Technical documentation. So what this is being able to take the 3D models that you create, and using a product that we have called 3D Via Composer is to author and create all kinds of different manuals, whether you're making spare parts lists, user training manuals. You basically you can take the 3D models and use it to create either web-based content or just traditional 2D print. These are examples of some of the types of things you could do if you want to do animations to show how something's put together, if you want to do a printed manual type of a thing, or if you want to do web-based exploded views, you can do those kinds of things. SolidWorks simulation. This is something I was going to kind of walk through an example just of doing fluid flow. So we have a design of this enclosure, right? We can basically simulate all different things from fans to heat pipes. For those of you guys who are using Flow, we actually just at the end of last year, we released a new module that has really extensive capabilities for doing electronics specifically, really extensive new material libraries, as well as being able to specifically simulate heat pipes, 2 resistor components, joule heating, a lot of new capabilities for doing specifically PCB and electronic enclosure type thermal analysis with fluid flow. So basically we can look at this, we can see that, okay, in this design we have, this is how the air is flowing through it. Let's see what happens if we put a vent on here. We can see what the new temperature profile is gonna look like. And actually the interesting thing about this is the components are actually hotter with the vent, because right here where I have these 2 fans, basically at the bottom, it was just gonna blow the air right out the vent. So this was an interesting little case study that we did. Where actually by putting extra vents into the enclosure, the cooling was way less. So the types of things that are maybe not even intuitive to you and then cause big problems down the line can really be kind of uncovered earlier in the design process if you are doing things like fluid flow simulation to understand the temperature profiles. So you can see by having these fans here, it was really just sucking the air right out of the vents. So then we move the vents from that side to the other side, and then we get a much more uniform cooling profile across the entire model, and then therefore much better performance, etc. So just by simply moving the location of the vents, we can get a much better overall cooling in the entire system. So those are, again, being able to just iterate through a lot of different concepts quickly, just by simply doing something like moving vents, but being able to run those types of simulations quickly is really, really effective. And then the last thing is SolidWorks PDM, Enterprise PDM. I'm just gonna get right to this last slide here, which is talking about the capabilities of PDM that I think are really important for people who are working with electronics. Because obviously with Enterprise PDM, you can manage not only the mechanical CAD files with all the associativity that you'd expect, we can also handle managing all of the electrical CAD files. And the key there is that you can provide physical links between the mechanical CAD files and the electrical files. So in terms of releasing a release process, you can have the release of the board files being tied to the electrical files, as well as being able to manage the electronics designs in the mechanical BOM, so that the assembly knows what version of the PCB it was tied to. So directly from say your Cadence Allegro type files, you can have that being linked directly into the SolidWorks bill of materials, so you know specifically what version of what is being built between mechanical and electrical. That's one of the things that's really kind of I think that people who are really moving forward with a good data management practices are starting to really take a look at managing everything together like that. As well as being able to do things if you are using AutoCAD for some crazy reason, if you are doing that, we can also use this to now auto-populate all of the AutoCAD block files, block properties, so then now all the data that you're managing in your database is going to be pushed directly into the blocks in AutoCAD, so that all your title blocks are going to be correct in real time from the database. And then, yeah, like I said, with the MCAD and ECAD files. So I think I went over my time. Thank you guys very much. We obviously have a big community here for you. We're here for you. I present at user groups all the time in the West Coast, so maybe you've seen me there before. If you're not, you should go to more user group meetings because they're awesome. And check out the forums and these blogs, and come by our booth 3401 over in the front, and we will give you guys a more detailed demonstration if you'd like. Thank you very much.